Now let's see what this topic is all about, what all we have to do in this topic. And for that, let's solve some questions together, try to understand the concepts and their applications, for which you'll have to join me on my iPad. Hello everyone, in this lesson we'll be discussing P3 differentiation. P3 differentiation is based on P1 differentiation. You need to know all the formulae, all the relationships from P1 to be able to solve questions in P3. So let's quickly overview the concepts we studied last year. So the derivatives you should know a series of these functions. So quickly let's write down the derivatives of all these functions you see. 5x. The derivative of 5x is just 5. So the first one is just a 5. Then when there's a power, you bring the power down and subtract 1 from the power. In general, if you have x power n, the derivative is n times x power n minus 1. So bring the power down and subtract 1 from the power. So we'll do the same thing here. We'll bring the 3 down and subtract 1 from the power, which makes it 7 into 3, 21 x squared. This is the derivative of the second function and this last function. This is based on the chain rule, but then just remember, whenever you have a power, deal with the power first. So bring down the power, copy the inside function as it is, and subtract 1 from the power. But that's not it. You have a function inside the bracket as well. So the next thing is to multiply with the inside derivative, which is the derivative of 3x plus 2. Now derivative of 3x is 3 and 2 is a constant, so the rate of change or the derivative is 0. So it's just 3. And combined we get 12 times 3x plus 2 power 3. So these are some derivatives which are purely from P1. And then besides this, we also studied something very important, which I just mentioned, the chain rule. Now, when do we need to use the chain rule and what is it? Let's see. So chain rule is basically involved when you have more than two variables. Let's say you have x, y, and then maybe t. If you have more than two variables, could be 3 or 4, you will have to use the chain rule at some point or the other. So let's assume we have 3 variables x, y, and t. 3 variables x, y, and t, but once again, it could be any 3. And let's say we have x as a function of t. We have y as a function of t. Basically, we have x and y in terms of t. What we have to find is y in terms of x, or maybe dy by dx. So to find dy by dx in particular, you will have to use a chain rule. You do not have y in terms of x, at least as of now. So you cannot just differentiate that function. You do not have y in terms of x, so you can't find dy by dx directly. What you can do is, you can find the derivatives from the two equations you see above. So what you want is dy on top, and you want dx in the denominator. I'll place the third variable in such a way that it's there, but its effect, it's cancelled out. So I'll place dt here and dt here. And these two derivatives I can easily find from the given two functions. From here I can find dy by dt because y is in terms of t. From here I can find dx by dt. But then what I want is dt by dx. So dt by dx is nothing but just the reciprocal of dx by dt. And now with these two derivatives and this chain rule, you can easily work out the rate of change in y with respect to x, the slope of the tangent, or just the gradient of the curve. And all of these are basically dy by dx. So this is a quick recap of P1 concepts. In the next lesson, we'll discuss some new relationships, some new formulae, and a lot of new derivatives, which are part of P3 differentiation. Hope you understood everything we discussed today. All the applications are as it is from P1, but yes, we have some new derivatives, we have some new integrals, and some new formulae, which we are going to discuss in these lessons. Hope everything is clear, but still, if you have any queries, you can always approach us in the discussion box below.